Welcome to our channel, where we bring you the most interesting and informative content from around the world. Look up at the night sky, preferably on a clear night, far from city lights. A faint, milky band stretches across the cosmos. This is our Milky Way Galaxy, a vast collection of stars, gas, dust, and planets. Its beauty has captivated humanity for millennia. Imagine standing on the edge of the Grand Canyon, awestruck by its immensity, but our galaxy dwarfs even that natural wonder. The Milky Way is not just a random scattering of stars, it has structure. Imagine a fried egg with a central bulge and a flattened disk. This is similar to our galaxy's shape. The central bulge is a dense region packed with stars, while the disk is where our Sun and most other stars reside. Our galaxy, like others, is a constantly evolving, dynamic entity. It's composed of several key components: the bulge, the disk, the halo, and spiral arms. The bulge is at the center, a dense region packed with older stars. It's thought to harbor a supermassive black hole, an object of unimaginable density. The disk, where our Sun resides, is a flattened region containing mostly younger stars, gas, and dust. Within this disk are spiral arms, areas of intense star formation. These arms are like traffic jams, where gas and dust clump together, leading to the birth of new stars. Surrounding the disk and bulge is the halo, a spherical region containing old stars and globular clusters, which are tightly packed groups of ancient stars. The halo is also thought to be filled with dark matter, an invisible substance that interacts gravitationally with normal matter. The Milky Way is constantly rotating, although not as a solid object would. The stars and gas in the disk orbit the galactic center, with those closer to the center orbiting faster than those farther out. Our Sun, located about two-thirds of the way out from the center, takes about 225 million years to complete one orbit. To truly grasp the Milky Way's size, let's use some mind-boggling comparisons. Imagine shrinking our Sun, a star with a diameter of 1.4 million kilometers, down to the size of a grain of sand. On this scale, the Earth would be smaller than the tiniest speck of dust, barely visible to the naked eye. Now, picture our entire solar system, which extends out to the orbit of Neptune, about 4.5 billion kilometers away. Even at this scale, our shrunken solar system would fit comfortably within the confines of a football field, with the Sun at one end zone and Neptune at the other. But where would the nearest star be in this model? Proxima Centauri, our closest stellar neighbor, is about 4.24 light-years away. In our shrunk-down model, it would be located over 4,000 kilometers away, roughly the distance between London and Cairo. This mind-bending exercise illustrates the incredible vastness of space, even within our own galaxy. It's a humbling reminder of our place in the universe, a tiny oasis of life in a sea of stars. Let's embark on a hypothetical journey across the Milky Way, traveling at the speed of light, to further grasp its immensity. As we leave our solar system, we'd encounter vast clouds of interstellar gas and dust, the remnants of exploded stars and the raw materials for new ones. After traveling for about 4.24 years, we'd reach Proxima Centauri, our closest stellar neighbor. It's a red dwarf star, significantly smaller and cooler than our Sun. From there, our journey would continue past other stars, some similar to our Sun, others much larger or smaller. As we venture farther from the galactic center, the density of stars would decrease, and we'd encounter more open space. We might even come across rogue planets, planets that have been ejected from their star systems and now wander the galaxy alone. Even traveling at the speed of light, our journey across the Milky Way would take 100,000 years. It's a journey that highlights the limitations of our current technology and the vastness of the universe we inhabit. Estimating the number of stars in the Milky Way is a daunting task, akin to counting grains of sand on a beach. Astronomers use various techniques, such as measuring the galaxy's mass and luminosity, to arrive at an estimate. Current estimates suggest that our galaxy contains hundreds of billions of stars, possibly even trillions. It's a number so large that it's difficult to comprehend. Imagine every person on Earth having billions of stars to themselves. These stars are not evenly distributed throughout the galaxy. They are concentrated in the bulge and disk, with fewer stars in the halo. The types of stars also vary, with older, redder stars found in the bulge and halo, and younger, bluer stars in the disk. The sheer number of stars in the Milky Way suggests that there could be countless planets orbiting them. Some of these planets might be similar in size and composition to Earth, potentially harboring life. The Milky Way is just one of billions of galaxies in the observable universe. Our galaxy is part of a group of galaxies called the Local Group, which contains over 50 galaxies, both large and small. The largest galaxy in the Local Group is Andromeda, a spiral galaxy even larger than the Milky Way. It's located about 2.5 million light-years away and is on a collision course with our galaxy. Don't worry, the collision won't happen for another 4 billion years. Beyond the Local Group, there are countless other galaxies, some clustered together in groups and clusters, others scattered throughout the vastness of space. These galaxies come in various shapes and sizes, from spirals like our own to elliptical galaxies and irregular galaxies. The Milky Way is but one thread in the vast cosmic tapestry, a complex and interconnected web of galaxies stretching across the universe. The Milky Way is not just a random collection of stars and gas, it's our cosmic home. It's the galaxy where our sun was born, where our solar system formed, and where life as we know it emerged. The Milky Way's location within the universe, its chemical composition, and its structure have all played a role in making life possible. Our galaxy is located in a relatively quiet part of the universe, far from the intense radiation and gravitational forces of galaxy clusters. The Milky Way is also rich in heavy elements, such as carbon, oxygen, and nitrogen, which are essential for life. These elements were forged in the cores of stars and scattered throughout the galaxy when those stars exploded as supernovae. The Milky Way's spiral structure also plays a role in the distribution of life-supporting elements. The spiral arms, with their intense star formation, are like cosmic nurseries, enriching the galaxy with the building blocks of life. While we've learned much about the Milky Way, there are still many mysteries to unravel. One of the biggest mysteries is dark matter, an invisible substance that makes up the majority of the galaxy's mass. Astronomers have inferred the existence of dark matter from its gravitational effects on visible matter. The rotation of stars and gas in the Milky Way's disk suggests that there must be more mass present than we can see. Dark matter doesn't emit, absorb, or reflect light, making it incredibly difficult to detect directly. However, its gravitational influence is essential for holding the Milky Way together and shaping its structure. The nature of dark matter remains one of the biggest unsolved problems in modern astrophysics. Despite its vastness and complexity, we are constantly learning more about the Milky Way. Astronomers use a variety of telescopes, both on Earth and in space, to study our galaxy in different wavelengths of light. Ground-based telescopes, such as the Very Large Telescope in Chile, provide stunning views of the Milky Way's visible light. Space telescopes, such as the Hubble Space Telescope and the James Webb Space Telescope and the James Webb Space Telescope, observe the galaxy in infrared and ultraviolet light, revealing hidden details obscured by dust. Radio telescopes, such as the Arecibo Observatory in Puerto Rico, detect radio waves emitted by objects in the Milky Way, providing insights into the galaxy's structure and the processes occurring within it. As our technology advances, so too will our understanding of the Milky Way. Each new observation brings us closer to unraveling the mysteries of our cosmic home. Studying the Milky Way provides us with a humbling perspective on our place in the universe. We are but a small part of a vast and ancient structure, a tiny speck of life in a sea of stars. Yet, this realization should not fill us with insignificance but rather with wonder and a thirst for knowledge. The Milky Way is a place of immense beauty, complexity, and mystery, a cosmic playground for our curiosity. As we continue to explore our galaxy, we are reminded of the interconnectedness of all things. The atoms in our bodies were once forged in the cores of stars, and the molecules that make up our planet were once scattered throughout the Milky Way. The Milky Way is not just a galaxy, it's a testament to the power of the universe to create awe-inspiring structures and to the potential for life to emerge in the most unexpected of places.
Andromeda Galaxy. On a clear night without a moon, far from any city lights, as we glance up, thousands of stars are sparkling above us. Yet, this is a very small part of all the stars that comprise the Milky Way Galaxy, our home in the universe, beyond what the night sky can show us. Outside the Milky Way, there are billions of other large galaxies and hundreds of billions of other stars. The closest huge galaxy to us is our sister galaxy, Andromeda, which is that brilliant smudge of light in the distance. The furthest object most of us humans can see with our unaided eyes is ours. It is about 2.5 million light-years away from Earth, a truly enormous distance. Fortunately, however, this simulation allows us to travel beyond the speed of light. In the blink of an eye, we can exit our solar system. Currently, all that remains of the planet on which every single human has ever lived is a small speck. The Sun. Merely one more star among many brilliant dots. Therefore, we need to travel more than 500 light-years to fully comprehend the Milky Way Galaxy's immense size. Light-years vertically, a trek that will let us witness the full splendor of our planetary galaxy. A barred spiral galaxy, the Milky Way is 13.6 billion years old. The cosmos appears to be covered in gigantic pivoting arms, forming a disk with a diameter greater than 100,000 light-years. It's unbelievable to consider that one of the countless stars that make up this galaxy is our star, the Sun. Nonetheless, the number of stars in it has been predicted to range from 100 billion to 400 billion. Look into the distance as we travel farther away from the Milky Way's brilliant glow, and you will saw a lot of eerie shimmering dots. These are whole galaxies that are dispersed throughout the universe that can be seen. You may see that the galaxies are not dispersed randomly. Instead, they are arranged in clusters that are gravitationally bonded. There are enormous dark voids scattered throughout the universe, giving it a wonderful cobweb-like structure. The number of galaxies in the observable universe is at least 100 billion. Yet, there may be trillions of them, and they are available in a wide range of sizes and shapes. After all, the majority of these galaxies are incredibly far away, and are only visible with extremely powerful telescopes. Yet, some are, cosmologically speaking, relatively close to the Milky Way, close enough to be part of what's termed the local group. At a radius of around 10 million light-years, this group is a massive cluster of more than 30 galaxies. Around light-years, the Milky Way is only one of the local group's 3 massive galaxies, although it's not the biggest. That would be the Andromeda Galaxy, towards which we are currently traveling. Andromeda, like the Milky Way, is a barred spiral galaxy with massive, encircling arms rich in gas, dust, and brilliant stars. Andromeda is a hugely greater than the Milky Way, though, covering a region that is, on a clear night without a moon, far from any city lights. As we glance up, thousands of stars are sparkling above us. Yet, this is a very small part of all the stars that comprise the Milky Way Galaxy, our home in the universe, beyond what the night sky can show us. Outside the Milky Way, there are billions of other large galaxies and hundreds of billions of other stars. The closest huge galaxy to us is our sister galaxy, Andromeda, which is that brilliant smudge of light in the distance. The furthest object most of us humans can see with our unaided eyes is ours. It is about 2.5 million light-years away from Earth, a truly enormous distance. Fortunately, however, this simulation allows us to travel beyond the speed of light. In the blink of an eye, we can exit our solar system. Currently, all that remains of the planet on which every single human has ever lived is a small speck. The Sun. Merely one more star among many brilliant dots. Therefore, we need to travel more than 500 light-years to fully comprehend the Milky Way Galaxy's immense size. Light-years vertically, a trek that will let us witness the full splendor of our planetary galaxy. A barred spiral galaxy, the Milky Way is 13.6 billion years old. The cosmos appears to be covered in gigantic pivoting arms, forming a disk with a diameter greater than 100,000 light-years. It's unbelievable to consider that one of the countless stars that make up this galaxy is our star, the Sun. Nonetheless, the number of stars in it has been predicted to range from 100 billion to 400 billion. Look into the distance as we travel farther away from the Milky Way's brilliant glow, and you will saw a lot of eerie shimmering dots. These are whole galaxies that are dispersed throughout the universe that can be seen. You may see that the galaxies are not dispersed randomly. Instead, they are arranged in clusters that are gravitationally bonded. There are enormous dark voids scattered throughout the universe, giving it a wonderful cobweb-like structure. The number of galaxies in the observable universe is at least 100 billion. Yet, there may be trillions of them, and they are available in a wide range of sizes and shapes. After all, the majority of these galaxies are incredibly far away, and are only visible with extremely powerful telescopes. Yet, some are, cosmologically speaking, relatively close to the Milky Way, close enough to be part of what's termed the local group. At a radius of around 10 million light-years, this group is a massive cluster of more than 30 galaxies. Around light-years, the Milky Way is only one of the local group's 3 massive galaxies, although it's not the biggest. That would be the Andromeda Galaxy, towards which we are currently traveling. Andromeda, like the Milky Way, is a barred spiral galaxy with massive, encircling arms rich in gas, dust, and brilliant stars. Andromeda is a hugely greater than the Milky Way, though, covering a region that is more than 200,000 light-years broad. More stars are thought to be present, perhaps as many as 1 trillion. That luminous bulge within its center conceals a puzzling supermassive black hole that is estimated to be 516 million miles, 830 million kilometers, in circumference. Greater than the orbit of Jupiter. There is 140 million suns worth of mass in it. Compared to Sagittarius A, the Milky Way's supermassive black hole, which only contains the equivalent mass of 4 million suns. It is gigantic, this supermassive black hole. Nevertheless, more than just individual stars circle this massive black hole's center. Galaxy M110 is the name of the brilliant, yellowish object off to the side of a large number of satellite galaxies that Andromeda is gravitationally connected to. These smaller galaxies have amazing stellar populations of their own, all of which, along with the galaxies and everything within them, revolve around their own centers. Circles Andromeda, similar to how the Earth and Moon both orbit the Sun while the Moon orbits the Earth. The Milky Way Galaxy is around 2.5 million light-years away from the Andromeda Galaxy. But that won't always be the case, due to the fact that both are headed in the same direction. Ultimately change each galaxy's structure for all time. There is a surge of galaxies, around 70 miles every second, or 112 kilometers per second, brings them closer to one another. And the predicted start time for the collision is 4.5 billion years from today. Although it might appear that this collision will only result in destruction. Extreme bursts of star production are frequently caused by galaxy mergers, leaving a flood of brilliant, brand new stars in the night sky. Although regrettably, very likely, the human race won't exist for very long to witness this magnificent cosmic spectacle. No matter what we will miss in the future, we can do one thing right now: step outside on a clear night and gaze above. Locate the Andromeda constellation, then the galaxy, and the only object we can see with our unassisted eyes that isn't a part of the Milky Way is something to behold. But it will eventually merge with our galaxy to form the Milky Way Galaxy. Did you have fun traveling to Andromeda? If so, please share in the comments below.
Look up at the night sky, far from city lights. What do you see? Thousands of stars, like tiny diamonds scattered on black velvet. Each star is a sun, some smaller, some larger than our own. But they are not scattered randomly. They are grouped together in vast, swirling collections called galaxies. Our own galaxy, the Milky Way, contains hundreds of billions of stars, and it's just one of trillions of galaxies in the observable universe. Understanding galaxies is crucial to understanding the universe itself. Join me now on a journey through time and space, as we explore the fascinating world of galaxies. To understand the origin of galaxies, we must rewind the cosmic clock to the very beginning, the Big Bang. Roughly 13.8 billion years ago, our universe burst forth from an extremely hot, dense state, expanding and cooling over time. In the universe's infancy, there were no stars, no galaxies, only a seething cauldron of elementary particles and radiation. As the universe expanded and cooled, protons and neutrons combined to form the first atoms, primarily hydrogen and helium. This early universe was not perfectly smooth. Tiny quantum fluctuations, present at the moment of the Big Bang, created regions of slightly higher density. These density fluctuations, amplified by gravity over millions of years, would serve as the seeds for the future formation of galaxies. As gravity drew matter together within the overdense regions, vast clouds of primarily hydrogen and helium gas began to collapse. These clouds, called protogalactic clouds, were the progenitors of galaxies. As a protogalactic cloud contracted under its own gravity, it began to spin faster and faster, much like a spinning figure skater pulling in their arms. This rotation flattened the cloud into a disc-like structure, with a denser bulge forming at the center. These were the first stars, blazing giants that illuminated the early universe. These explosions enriched the surrounding gas, with heavier elements, setting the stage for the next generation of stars. Gravity continued to play a dominant role in shaping the evolution of galaxies. Galaxies are not static, unchanging islands in space. They are dynamic systems, constantly in motion under the influence of gravity. Stars within a galaxy orbit around the galactic center, their paths shaped by the combined gravitational pull of all the matter in the galaxy. Spiral galaxies, like our own Milky Way, have a central bulge and graceful spiral arms, where star formation is actively taking place. Elliptical galaxies are smoother and more rounded, with less gas and dust and older stellar populations. Galaxies are clumped together in clusters and superclusters, interconnected by filaments of gas and galaxies, forming a vast cosmic web. Section 5, Star Birth and Death, the Engines of Galactic Evolution. Stars are the fundamental building blocks of galaxies, and their life cycle plays a crucial role in the ongoing process of galactic evolution. Stars form within dense clouds of gas and dust, known as molecular clouds. Here, gravity overcomes the outward pressure of gas, causing the cloud to collapse under its own weight. As the cloud collapses, it fragments into smaller clumps, each of which can potentially form a star. This process is both intricate and fascinating, leading to the birth of new stars. Massive stars live fast and die young, exhausting their nuclear fuel quickly and ending their lives in spectacular supernova explosions. These supernova explosions are incredibly powerful, releasing vast amounts of energy and enriching the surrounding interstellar medium with heavier elements, essential for the formation of new stars and planets. Our own Sun and Solar System formed from the remnants of previous generations of stars, enriched with the elements necessary for life to arise. This cosmic recycling process is fundamental to the evolution of galaxies and the universe as a whole. Section 6. Galactic Collisions, a Dance of Titans. Galaxies are not isolated islands in space. They are engaged in a constant cosmic dance, their movements influenced by the gravitational pull of their neighbors. Occasionally, this dance leads to a spectacular collision. When galaxies collide, they don't simply smash into each other like billiard balls. Instead, their gravitational fields interact, distorting their shapes and triggering bursts of star formation as gas clouds are compressed. These collisions can be incredibly energetic, lasting for millions or even billions of years. Stars themselves are unlikely to collide directly due to the vast distances between them. Our own Milky Way Galaxy is on a collision course with our nearest large neighbor, the Andromeda Galaxy. Section 7. Dark Matter, the unseen hand guiding galactic destiny. While we can observe stars, gas, and dust in galaxies, there is a mysterious component that dominates their mass: dark matter. This enigmatic substance makes up about 27% of the universe. Dark matter doesn't interact with light, making it invisible to telescopes, but its gravitational influence is profound. It bends light from distant stars and galaxies, a phenomenon known as gravitational lensing. The existence of dark matter is inferred from its gravitational effects on visible matter. Without it, galaxies would fly apart. Galaxies rotate much faster than they should based on the visible matter alone, suggesting that a halo of unseen matter must be providing the extra gravity to hold them together. This unseen matter is dark matter. Dark matter plays a crucial role in galaxy formation and evolution. It acts as a cosmic scaffold, guiding the formation of structures in the universe. The gravitational pull of dark matter halos is thought to have drawn in the gas that formed the first stars and galaxies. Without dark matter, the universe would look very different. Unraveling the mystery of dark matter is one of the most significant challenges in modern astrophysics. Scientists around the world are working tirelessly to understand this invisible force that shapes our universe. Section 8. Types of galaxies, a diverse cosmic zoo. Galaxies come in a wide variety of shapes and sizes, each with its own unique history and properties. Astronomers classify galaxies into different types based on their morphology, or appearance. Spiral galaxies, like our own Milky Way, are characterized by their graceful spiral arms, a central bulge, and a surrounding halo of stars and dark matter. Elliptical galaxies are smoother and more rounded than spiral galaxies, with less gas and dust and older stellar populations. Irregular galaxies lack a defined shape, often the result of gravitational interactions with other galaxies or internal processes like starbursts. This diversity of galactic types reflects the complex interplay of gravity, star formation, and galactic interactions that have shaped the universe over billions of years. Section 9. Active galactic nuclei, the hearts of darkness. At the center of many galaxies, lurking within the central supermassive black hole, lies a region of intense activity known as an active galactic nucleus, or AGN. These AGN are among the most luminous and energetic objects in the universe. As matter falls into the supermassive black hole at the center of an AGN, it forms an accretion disk, a swirling disk of gas and dust heated to millions of degrees. AGN can be incredibly powerful, outshining the combined light of all the stars in their host galaxy. The study of AGN provides insights into the physics of black holes, the processes that drive galaxy evolution, and the nature of the early universe. Section 10. The future of galaxies, fading giants and new beginnings. As we look to the future, the evolution of galaxies will continue to be shaped by the intricate interplay of gravity, star formation, and galactic interactions. These forces have been at work for billions of years, sculpting the universe into the magnificent tapestry we observe today. However, the universe is also expanding and cooling, which will have profound consequences for galaxy evolution. This expansion means that galaxies are moving further apart, and the cooling universe will affect the processes that drive star formation and galactic dynamics. As the universe expands, the gas clouds that fuel star formation will become more diffuse, making it increasingly difficult for new stars to form. These gas clouds, once dense and vibrant with activity, will spread out, leading to fewer regions where new stars can be born. Over time, galaxies will gradually run out of the necessary fuel, and star formation will cease. This will result in galaxies that are populated primarily by older stars, with fewer bright, young stars to light up the cosmos. Existing stars will continue to evolve, with low-mass stars like our Sun eventually ending their lives as white dwarfs, slowly cooling over trillions of years. These remnants will be the final stages of stellar evolution, marking the end of an era for many stars. Galactic mergers will continue to play a significant role in shaping the universe, with smaller galaxies merging to form larger ones. These cosmic collisions will create new structures and potentially trigger bursts of star formation in the newly formed galaxies. The universe of the distant future will be a very different place from the one we observe today, dominated by fading giants and a slowly dimming cosmic background. The once vibrant and dynamic universe will become a quieter, more subdued place, as the last remnants of star formation fade away. Section 11, Conclusion: Our place in the grand cosmic ballet. Our journey through the realm of galaxies has taken us from the fiery birth of the universe to the fading giants of the distant future. We have witnessed the awe-inspiring power of gravity, the elegant dance of galactic interactions, and the life cycles of stars. Galaxies are not merely distant objects in the night sky, they are vast, interconnected systems that have shaped the universe we observe today. We are all products of this grand cosmic ballet, our very existence intertwined with the life cycles of stars and galaxies.
Amazing Galaxies Facts. Here are the top 10 galaxy-related facts you probably didn't know. 1. The galaxy is a massive system of stars, gas, and dust held together by gravity. 2. Our Milky Way Galaxy is estimated to contain somewhere between 100 and 400 billion stars. 3. Galaxies come in three main shapes: spiral, elliptical, and irregular. 4. Spiral galaxies, like the Milky Way, have a central bulge and rotating arms of stars and gas. 5. Elliptical galaxies are much more spherical in shape, with most of their stars residing in the central bulge. 6. Irregular galaxies, as their name suggests, have a more haphazard shape and no well-defined bulge or arms. 7. The most common types of stars in galaxies are red dwarfs, which are relatively small and dim, and yellow dwarfs, which are about the same size as our own Sun. 8. Galaxies are thought to have formed through a combination of mergers between smaller structures and the collapse of gas clouds. 9. The distance between the stars in a galaxy is so vast that they are essentially isolated from one another, meaning that collisions are uncommon. 10. The study of galaxies has provided a wealth of information about the evolution of the universe as a whole, as well as insights into the physics of stars and the nature of dark matter. Thanks for watching. Please subscribe, like, share, and comments.